Hello students, today we will see 3.11 cells, EMF and internal resistance. Okay, so we know that to maintain a steady current in an electric circuit, cell is required. Cell consists of two electrodes, positive electrode and negative electrode. Positive electrode is known as an anode and negative electrode is known as a cathode. These two electrodes are immersed deep inside the electrolyte, so there is an exchange of charges between this electrode and electrolyte. Okay, let V plus is potential difference between positive electrode and electrolyte, and adjacent to it is marked as A in a figure. Minus V minus is the potential difference between negative electrode and electrolyte itself, so over here it is marked as B in a figure. So over here, when there is no current flowing in electrolyte, we can say that potential difference across the electrolyte is same throughout. Okay, so potential difference between P and M is, let it be V. So V is equal to, we can say V plus minus V minus, so it becomes V plus plus V minus. Okay, this potential difference across P and N is known as a electromotive force or EMF E. Okay, so over here you guys have to remember one thing, that it is not a force. EMF is not a force. Okay, it is a energy gain per unit charge, means it is a potential difference. Okay, now to understand the significance of this E, okay, we connect one resistor of value R across this cell. Okay, so current starts flowing from C to D. Current starts flowing from C to D through resistor R. Okay, so over here we can say inside this electrolyte, current flows from D to C. In the other words, we can say through resistance R, current flows from positive electrode to negative electrode, and through electrolyte, current flows from negative electrode to positive electrode. Okay, so this electrolyte has its own some resistance, means it has some finite resistance, which is known as the internal resistance of the cell. Okay, here I am denoting this internal resistance by R. Okay, ये इलेक्ट्रोलाइट है, उसका खुद का अपना कुछ रेजिस्टेंस होता है. ठीक है, तो उसको क्या बोलते हैं? सेल का इंटरनल रेजिस्टेंस बोलते हैं. ठीक है, तो यहाँ पे अब हम लोग दो केस कंसीडर कर लेते हैं. केस नंबर 1, when R has a infinite value. So when R is infinite, we can say current flowing through the resistor is 0, means no current is flowing through the resistor, or you can say no current is flowing through the cell. So over here it is also known as a open circuit condition. Okay, so let's see potential difference across P and N during open circuit condition. So potential difference V across P and N is potential difference across P and A plus potential difference across A and B plus potential difference across B and N. Okay, over here in open circuit condition, no current flows, so potential across A and B, we can say there is no current flowing through electrolyte, so PD across A and B is 0. So total V is equal to PD across P and A plus PD across B and N, and we already seen that it is equal to EMF E So in open circuit condition, terminal voltage across the two electrode is equal to electromotive force. Okay. Now let's see another case number 2. When R is finite, means value of R is finite. Okay, we know that value of R is finite, so current must be flow through this cell across the resistor as well. Okay, so in this condition, potential difference across P and A plus potential difference across B and N, which is equal to EMF E, and current is also flowing through electrolyte. Okay, so there must be potential difference across A and B. So over here, to calculate potential difference across A and B, we can say that is I is the current flowing through electrolyte and R is the internal resistance of this cell. Then potential difference across AB according to Ohm's law is IR. So V potential difference across A and B is IR. So terminal voltage across P and N, we can say, is equal to E minus IR. Over here, the negative sign in this term IR shows that charge is moving, or you can say current is moving through electrolyte from negative terminal to positive terminal. Once again, it is moving through electrolyte, means current is moving through electrolyte, or charge is moving through electrolyte from N to P. Okay, that's why this negative sign is appears. Or in the other word, we can also say due to this internal resistance R, some amount of energy is lost. That's why this negative sign appears over here. So when value of R is finite, current is flowing, so it is known as a short circuit condition. Okay, in short circuit condition, we can say terminal voltage across P and N becomes equal to E minus IR, while in open circuit condition, terminal voltage across P and N, which is V, is equal to EMF. Okay, so over here in practical situation, this term is kept very less. This term IR is kept very less, such that E is very greater than IR, or you can say IR is very less than E, means internal resistance of the cell is very less. Okay, now over here in this open circuit condition, we know that V is equal to E minus IR, where V is potential difference across P and N, across you can say C and D. So it is also, we can say it is also potential difference across the resistor R. So according to Ohm's law, we know that V equal to IR. So from this two equation, we can say IR is equal to E minus IR. So after simplifying this equation, value of I becomes E upon R plus R. Okay, now in a circuit, maximum current flows when this capital R is equal to 0. So value of that maximum current is said to be E by R when R is equal to 0.